Hello, I'm Mike Owen. I'm a university professor emeritus, but happy to rejoin you on Crops TV and discuss herbicide resistance, past, present, and in the future. And as it turns out, it's going to be a lot of past and present, but not so much in the future. Before I get too much into that, I want to remind everybody that we redid the herbicide guide for Iowa corn and soybean production. The URL is available at the bottom of the screen. This is a good and I think very in-depth opportunity for you to read about the herbicide recommendations that we have made for corn and soybean. And also, there are several articles that cover some of the topics that I won't be talking about, but I will talk a little bit more about the information about herbicide resistance. I have to apologize because a lot of these slides are, blasts from the past. Here we have one that I have sort of rhetorically entitled Weed Management, where we have mare's tail, or better said, horseweed field with some soybeans planted in. In reality, it's more of a weed field, and this was attributable to the farmer's inability, or if you will, unwillingness, to adapt to the changing populations of the horseweed in that particular field. Let's start out with a little bit of information about what we mean by herbicide resistance. The definition that has been accepted by the Weed Science Society of America, although challenged elsewhere, is the fact that this is an inherited characteristic of plants that survive the dose, as stated, that normally kills most of those weeds. And this is a selection process that was actually discussed by Charles Darwin back in the early or mid 1800s, where he described just how species, plants and animals, respond to selective forces that involve them in their environment. And the cause of herbicide resistance, I guess this is like no great surprise, is simply because we use the same control tactics. We have been through a number of waves, if you will, of herbicide resistance, starting out with the ALS resistance that was brought forward primarily by American cyanamide products Pursuit on water hemp, and then became a very large and costly feature in agriculture when everyone switched to the genetically modified glyphosate-resistant soybeans and corn and other crops. And then all of a sudden, none of the plants, water hemp, giant ragweed, and others, would respond to glyphosate. This is not just a herbicide feature, however, this evolutionary process that weeds, and as it turns out, pretty much every species adapts to. Here we have a number of factors. Grazing, we see the response of certain plants, this types of growth that keep the grazing process from happening. Tillage, adaptation to tillage is the development of rhizomes and rootstocks. And I've also have said in the past that water hemp has evolved resistance to cultivation. And one might ponder, how can that be? Well, look at how water hemp has the ability to germinate much later in the growing season, after the crops have closed in and cultivation is no longer an option. This is a selection pressure. Germination and dormancy is a heritable trait, and there is good evidence. In fact, we published this many, many years ago about how different water hemp populations germinate at different times, and probably have done so, this selectivity, have done so because of the strategies that were used to control it. Mowing, I think everybody is pretty well aware of how weeds adapt. We see yellow foxtail, for example, that grows in a prostate growth habit. Dandelions and plantain are the same thing. Hand weeding. There are many good examples of how the crop mimicry, where the weed has essentially looked or evolved a phenotype to look very much like the crop and eliminate the effectiveness of hand weeding. And then finally, what we are now dealing with worldwide, and in particular as a problem in Iowa, is the ability of certain weeds to evolve resistance, whether it be metabolic resistance or target site resistance, or even in some degree translocation that basically makes them not respond to herbicides. This is an oldie but a goodie. This is when there was a DuPont selling agricultural products, and they recognized, because of their ALS inhibitor herbicide chemistries, they realized that there needed to be a change in how we were managing weeds with herbicides. And they put forward what was a very good brochure, managing herbicide or managing weed populations to preserve herbicide value. This was in the late 1990s. And as it was designed to help farmers understand this evolutionary process of herbicide resistance and manage the evolving resistance to preserve the herbicide value. The rhetorical question that I ask, and again, this is from the 1990s, what did we learn from this attempt by DuPont to help preserve herbicide value? And the answer is not much. And this is unfortunate because we have now gone through the third or the fourth wave of resistance to different herbicides that are being used. Here is the glyphosate-resistant weeds that we have as major economic problems. We have common water hemp. We have common ragweed further east and south, horseweed or mare's tail in Iowa. Palmer pigweed has come into the state through introduction using contaminated weeds, prairie plantings, and also equipment, giant ragweed, and then further south we have Johnson grass. All of these are major issues in their respective crop production systems. All have evolved strong resistance to glyphosate and made that herbicide essentially useless in many instances. And those of you who have glyphosate-resistant water hemp here in Iowa fully appreciate what little glyphosate now does in glyphosate-resistant crops. Before I retired in 2011, and working in conjunction with the Iowa Soybean Association, we started to do a survey to determine how big of a problem herbicide-resistant weeds in Iowa actually was. And we focused on water hemp, and we focused on soybeans simply because it was easier to find the escapes later in the season prior to harvest. And we did the first sampling in 2011. We did a 2012 sampling, and then I recognized that while it was good information, it was not particularly valuable from a predictive perspective. And so in 2013, we established a specific algorithm that predicted certain fields in the 9 crop reporting districts across Iowa and told us which fields we should survey such that we would have a predictive value at the 95% confidence interval. What this means is that these fields that we looked at in 2013 allowed us to predict at the 95% confidence interval, meaning we were right 95% of the time, which fields would have resistance. And we tested these populations against 5 different herbicide mechanisms of action. And the reason we did this is try to get a handle on how quickly the weeds in those fields, those escaped, would expand and become major problems across those fields. And here is essentially a diagram that shows after so many years when you're going to have herbicide resistance, and we'll say herbicide resistance in water hemp, how, across the field. And it takes 5 to 7 years before a farmer recognizes this is not just an escape, it's not a sprayer skip or whatever. And once this trait is maintained in the field 8 or 9 years, a majority of the water hemp in that field will have the herbicide resistance characteristic. Now, what does this mean? And here's a little slide, and I think Dr. Hartzler actually put this together, and it talks about, okay, how many plants escaping actually become a major problem. And I think you can look at the math. I'm not going to read this, but essentially, even if you have 95% control with just a few escapes in a field, 95% control, you'll end up with possibly one water hemp plant per square foot across this entire field. And if those escapes have herbicide resistance, it's going to be a major economic problem for you to manage. So right now, I think this represents the reality of herbicide resistance in most fields. All right, just edges on the field, maybe where you introduced it when you brought a combine in that had been in a field with herbicide resistance. Maybe it's an area where there was a wet hole or something like that. But these plants did experience whatever herbicide regime you were using. And it doesn't look to be such a major problem that you can't just go through and combine that area, okay? But let's think about this. If you go through, and the best machine I know to spread weed seeds widely and evenly across a field is an axial flow combine. And so if you go through this and harvest this area, those weed seeds are going to get spread further and further across the field. And if you do tillage, that tillage will spread those weed seeds further and further and more evenly across the field until you end up with a problem like that first slide that I showed you, where it was not weed management, but rather a weed. This is perhaps a little bit difficult, but I'll go through it hopefully very specific. This is what happened with the 2013 in the red bars and the 2019 repeat survey that was done on the same fields. And again, looking at how resistance was changing over that 6-year production system. We see in the atrazine that 76 or so percent of the fields that we picked at random, which again provides us with the statistical ability to predict if resistance is going to exist in any field. And based on that, in 2013, at the 1x rate of atrazine, about 76% of the fields had resistance. When we went back in 2019 and repeated the survey and repeated the screening that we did in the greenhouse, we found that resistance to atrazine at the 1x level had increased somewhat, but importantly, it had not declined. We go now to the right, we look at glyphosate, and we see glyphosate has increased, almost to 80 or 90% in 2019. Imazethapyr, representing the ALS inhibitor herbicides, was very high in 2013 and increased in 2019. lactofen, which represents the PPO inhibitor herbicides, we really didn't see resistance in 2013, but in 2019, it is climbing into the 20% range. And then similarly at the 1X rate, we looked at mesotrione as the representative of the HPPD inhibitor herbicides, and the resistance at the 1X has now increased up to about 15% of the fields are likely to have water hemp with HPPD resistant characteristics. As we go to the right and we see under B, this is the same response but using 4 times the herbicide rate. And as you might expect, in many instances, the relative percentage of fields that had resistance was a little less. But if we look at the pursuit, or imazethapyr, we see that it's still very high, and we are now seeing a high level of resistance in about 5% of the fields to the PPO inhibitors and about 3% to the HPP inhibitor herbicides. This is important because these indicate at the 95% confidence interval, being right 95 times out of 100, what percentage of fields are likely to have traits, resistant traits to these herbicides. This is the other issue that using these herbicides and repeating their use has caused, and that is the fact that the same herbicide-resistant population of water hemp probably has resistance to other herbicides that were used in the field. Again, the same basic layout. On the left in the graph A, red 2013, gold 2019, we look at resistance to one of the 5 herbicides, and in 2013, we had about 10% of the populations that we selected had only one resistance. In 2019, at the 1X rate, there were no populations that we selected that had one-way resistance. That is because they had evolved resistance to other herbicides. Two-way, which was a main problem in 2013, two-way resistance declined in 2019 down to about 20% of the populations. But three-way now is greater in 2013 and even greater still in 2019. Four-way resistance, which wasn't a major issue in 2013, the cardinal red, increased, almost doubled in 2019, and 5-way resistance, which we didn't discover in 2013, is now showing up in about 6 to 8% of the populations. And in graph B, the same thing, but with the 4X rates of the herbicides, and we can see that it has become a major feature in both 2013 and again in 2019. So what is the prevalence of multiple resistant water hemp comparing 2013 to the left to 2019 on the right? And here in 2013, we see that essentially there's no 5-way resistance. In 2019, one-way resistance went away. Two-way resistance has increased a little bit. Three-way resistance has increased considerably, and 4-way and 5-way resistance are showing up. Essentially, in 2013, 52% of the water hemp populations, which actually means 52% of the fields in Iowa, have water hemp with 3-way or more herbicide resistance. And in 2019, this number has jumped up to 80% of the fields have water hemp with 3-way resistance traits or more the 4 and the 5-way resistance. This leaves precious little opportunity if these water hemp populations have increased to the point where they are a major factor in that soybean or corn field. So we've looked at the past, we've looked at the present situation, and now let's look a little bit at the future. This is some work that we published with Ryan Hamburg, who is an Iowa kid who is now at the Texas A&M University working on his PhD. And here we looked at populations that were not selected randomly, but rather selected arbitrarily. And they were challenged with 2,4-D, they were challenged with dicamba, and they were challenged with glufosinate. And what we're looking at is the survival frequency. This is not to suggest that this is actual resistance, but I think it gives a fairly strong indication that there are populations that are not going to respond very well to most of these herbicides. We look at those that survived at less than 10%, and the predominant number, 75 of the populations for 2,4-D, 108 of 133 total populations survived dicamba, and 145 populations out of 168 survived glufosinate. But as we go further and we look at the frequency of survival, 20 to 30% and so forth, we see that these numbers increase up to almost 50% or more of the populations survived 2,4-D, none of the populations for dicamba, and none of the populations for glufosinate. We have to recognize, however, that in other areas, not with water hemp, but with Palmer pigweed, which again is becoming a problem in Iowa, we are finding high levels of dicamba resistance in populations, and we're finding lower levels of populations that are resistant to glufosinate. Will we have options in the 30s for managing these herbicide-resistant weeds? And let's recall that we have not seen any new herbicide mechanisms of action registered since the late 90s. And so we've gone almost 30 to 40 years without any new herbicides. Now, new herbicides have been registered, but they are the same mechanisms of action that we have had in the past. And so let's look at the traits, 2,4-D, the enlist trait. We look at dicamba with the Bayer Crop Science dicamba resistance, and we look at the Liberty resistance that exists in soybeans. And here we find that there was resistance to 2,4-D discovered in 2012 in Nebraska. We see with Liberty that Palmer amaranth resistant populations were discovered in Arkansas in 2019, and dicamba resistance in water hemp in Illinois and in Tennessee is widespread and reported in 2019. The HG15, which is dual, metolachlor, and others of the HG15 site, resistance to that herbicide, dual, was reported in Illinois in 2019, and we have heard complaints about performance for dual in Iowa. And so these are the herbicides that we have been using for managing water hemp and Palmer amaranth, and we can see that resistance already exists in populations. And so into the 30s, we are going to have greater challenges using those herbicides that we have been using and the traits that those herbicides are registered for. And with the recent, this is February 8th that we're recording this on Crops TV, there was an announcement that the dicamba registrations have been revoked by courts out of Arizona because of failure for the EPA to follow proper procedure. And so whether or not we're able to use dicamba this growing season in corn or in soybean for that matter, becomes a bit of a question, and not a good question, as it were. So what can we do to manage herbicide resistance? And again, we are predicting that herbicide resistance in water hemp, those traits exist in a majority of the fields. That is not to suggest that the majority of the water hemp plants in those fields are resistant to herbicides, but it's a strong indication that the likelihood is that they will, if they have not already, evolved resistance to those particular herbicides. Well, we have had, if you will, a fool's paradise about the simplicity and the convenience of managing weeds with single applications or multiple applications of particular herbicides to which the crops have resistance. And this is not working. Simplicity and convenience has a price, and the price is that herbicide-resistant water hemp is evolving. Possible strategies include using multiple effective sites. But notice that I have highlighted effective. And given the multiple resistances that exist in a high percentage of the weed or in the water hemp populations in fields, whether or not they're effective, that is hard to suggest. We could also rotate effective sites of herbicide action, but again, without knowing exactly which weed or which herbicides are effective becomes a bit of a question. And so maybe this is not such a good strategy after all. And again, any strategy that is effective, regardless of whether it is based on herbicides or based on tillage, such as cultivation, if it is effective, it will eventually fail because of the ability of plants, and in specifics, water hemp, to evolve resistance to that effective trait. If that is the only thing that is used to manage the water hemp, which gets back to the simplicity and convenience. You need to use multiple strategies. Herbicides will still be an important consideration, but without including other techniques such as, where appropriate, using cover crops, and where appropriate, using cultivation, or increasing the diversity of crop rotation, which is not easy. Without using these other types of strategies, eventually the herbicide factors that are being used will fail. In summary, recognize that weeds, and in specifics, water hemp, will adapt to all management practices that you employ in crop production. And what we have found, particularly with herbicide-resistant traits, once a water hemp population evolves resistance to a particular herbicide characteristic, it will more quickly evolve resistance to other herbicide traits. And these traits are additive. They just stack up in the water hemp genome, and they do not go away whether or not you stop using that particular herbicide. They are still there. And that makes waiting a few years and then coming back to the same herbicide that was not performing several years ago, it still will not perform. Note that the diversity of the systems is critically important. The simpler the system, the less diverse the crop production system is, the more rapidly that weeds will adapt. And if this happens to be based on herbicides, the more quickly resistance will evolve. We recognize that current crop production systems are based on herbicides. This needs to change, not to eliminate the use of herbicides, but to add to the herbicide other diverse management practices. And obviously, changing tactics, using something like a cover crop or rotating tillage or changing crop rotation practices, this is not simple. This requires time. But it is critical that this be done, because ultimately and inevitably, whatever herbicide program you are using will fail. Concluding, resistance is a big problem. It's a global feature. Wherever herbicides are used, on whatever crop is being produced, resistance is evolving, and the evolution of herbicide resistance is increasing at an increasing rate. And this is to all herbicide mechanisms of action. There are none that do not have herbicide-resistant weed populations somewhere in crops. As a general statement, farmers still feel that resistance is not their issue. They are wrong. Industry is not really supporting, even though they give lip service to weed management and product stewardship. In reality, they, at the grower level or at the dealer level, they are doing little, if anything, to promote product stewardship to the extent that their customers are changing their behavior. This has to change. Even if new herbicides or new genetically engineered traits in crops were developed and marketed, this is not going to fix the problem. As I have indicated, once a weed population evolves resistance to a particular herbicide, they are now in a position where they or it will more quickly evolve new resistances. And as I've indicated, these resistances stack up, just like plant breeders stack up genetically engineered traits in crops. And so new herbicides and new genetically engineered traits are not the cure to the problem, regardless of what the marketing people say. And it is critical, imperative, that you focus and develop action to manage the herbicide-resistant weeds that exist in fields in Iowa, and develop a more diverse weed management program. These are the guys back in the 1800s that predicted water hemp resistance in Iowa. Chuck Darwin and Russ Wallace, they talked about the evolution of characteristics attributable to selection pressure. We are selecting herbicide resistance in crops, in weeds, using herbicides. This is what they predicted, and it is coming true. This is Mike Owen on Crops TV, and I thank you for the opportunity to provide this information.